Hello, my name is Reynold Greenlaw. I'm a director at Oxford Computer Consultants, and it's my pleasure today to introduce John Boyle and Kaz Librowski, who founded the company that I've worked for over 20 years. John Boyle did a PhD in artificial intelligence, expert systems applied to control systems, and this resulted in the MATLAB control systems toolkit, which is in wide use today. John joined OCC, built the company with Kaz, was managing director until 2018, became company chairman, and now leads our local government group in the marketplace team. John is also chairman of the Oxford Trust and advises companies that are startups or at early stage. And all this time he's been working with Kaz Librowski. Kaz came to the company from an industry background. So after studying physics, Kaz worked for big industrial engineering companies like Plessey, Rackell North, and Stuart Hughes. And right from the beginning, applying AI techniques to speech recognition and also to vibration analysis. Kaz started the group that I now have the pleasure of running, custom software team, now called Innovation Delivery. And Kaz is an expert in software application design and development. So it's my pleasure to introduce them and hand over to them for this interesting discussion on AI.
So John, perhaps you could tell us where OCC's interest in AI came from.
Yes, I think perhaps people don't realise that we actually set up OCC as a company offering services in AI. I just completed a PhD looking at how to design control systems using an emerging AI technology called expert systems. And the point was that the control systems were very complex to design and build. There were only a few experts in the world, and we wanted to try and find a way of capturing that expertise so that other engineers could then go and design and build their own control systems. But perhaps, Kaz, it would be worth explaining to people what expert systems are and were. Yeah.
Well, they were an early attempt at declarative programming, and I think most people involved in computing will recognize SQL as the more widespread implementation of that idea. And the point was to separate the complex business of inferencing, which required complex programming, from the actual information that the experts had. And so in the same way that if you're a data scientist, you will define your tables and your indexes, but you won't be interested in exactly how that data is laid down onto the disk in some optimal way so they can be retrieved quickly. That's all a grungy detail that you expect the computer scientists to figure out. So by analogy, the idea was that the experts would just state what their rules were, if this, then that. And all of the rules would then be combined in a manner that the experts didn't really care about, but that then enabled deductive conclusions to be made. So that's really what the expert systems were. They were a way to separate the grungy technology bit from the domain knowledge bit. And that domain knowledge was encoded predominantly in the form of if-then rules.
And I think what was interesting, what helped that technology to be adopted, was that you could trace back to see how a conclusion was reached. In other words, you could actually ask the system, well, which rules did you fire in what order in order to arrive at that conclusion, which I think compares interestingly with a lot of modern AI techniques that have become very much black box, where the mathematical models are no longer transparent to a human to understand how the decision was made.
Yes, although to some extent they were easy to understand because they were a lot smaller.
Well,
most of them were a lot smaller. But yes, you could trace them back. You'd also inspect the interim steps, the interim conclusions, and see whether they made sense. Quite often they didn't, because not all of the rules are absolutely perfect and correct. So
yes, I mean, I think that was quite interesting. So we set off setting up OCC in 1989, and we had brochures saying we can build you expert systems, and we used to send those out to anyone who would like to read our brochures. And indeed, we had some opportunities to build early expert systems. It was interesting some of the problems we ran into because certainly in my domain, which was the design of these control systems, and you have to realize it was being applied to the design of modern aircraft. And what people don't realize is that modern aircraft, particularly modern fighter aircraft, are inherently unstable. In other words, a human can no longer fly the thing. It actually is flown by a computer, or fly-by-wire as it's often called. And so there were two problems with capturing that expertise. One is there were very few good designers of the systems around, and they weren't very good at codifying their expertise as if-then statements. And I think they also slightly objected to having a couple of 20-year-olds coming up to them and say, would you mind giving me half an hour of your time so I can write down everything you know, and then I'll put it into a computer program. That we didn't get the psychology quite right.
No, although if they'd known the truth of it, they wouldn't have been so worried, would they?
Well, possibly not, no. And it's interesting, actually, perhaps just worth telling the story of how it happened, how we actually ended up getting together and starting the company, because at the time I worked for a company called GEC and you were working for a company called Stuart Hughes, and we found ourselves in Bremen in Germany on a research project looking at engine monitoring and condition monitoring on engines. And we were very young and naive. My boss only gave me one job all week, which was to find out which tram we had to take back to the airport to catch the flight home, which I did successfully, but we just got on the tram in the wrong direction. So it was the right tram, wrong direction, and we missed the flight. As a result of which our bosses paid for upgrades and went to Frankfurt and flew home immediately, but they wouldn't pay for that for us. We were stuck for 3 days in Bremen until the next flight back to the UK. And so we got to planning the idea of launching this company around that technology.
Whenever you tell this story, I'm reminded of, I think it's Charles Aznavour's song called "Ah Yes, I Remember It Well." There's an old couple, and one of them says one thing, and the wife constantly contradicts him. And I think there's echoes of that.
Yes, my wife always says that I never let a good story get in the way of the truth. Yes,
yes. No, we mustn't say that.
But I think it's just our memories, probably.
Yes, failing.
So I think perhaps to our disappointment, what this early foray into expert systems did is it actually established our credibility as software developers, and we were able to get a number of contracts as software developers, building all sorts of IT systems for customers. And we didn't really get back into AI work until 2014. And later on, I'm going to talk to Reynold Greenlaw, who heads up our innovation delivery team, about the work we've been doing in AI in the last decade. But I think it's interesting in a field that has moved on so much for various reasons to perhaps ask you what you think the main difference is between what is called AI today and what was called AI in 1989 are.
Well, I think any technology, when it sort of surges forward, it's normally for more than one reason. It's often because a number of things arrive and they interact with each other and spur each other on. And I think in the case of AI, the big difference is from 30 years ago. I mean, first of all, there is vastly, and I mean vastly more data, orders and orders of magnitude more data. Certainly some of the models we were doing, we could quite very nearly memorize all of the data we put into these models, whereas now you're talking terabytes and above. And the other thing is that we've now found a use for all of the kids sitting in their bedrooms playing video games. Everybody thought that was a tremendous waste of time, but what it did was it created a market for graphics cards with their GPUs, and of course what a GPU does is just does matrix multiplications largely, very, very quickly in parallel. And it turned out that this was perfect technology for accelerating neural network processing, which had been around. I mean, I first came across it in the mid-'80s, but it wasn't really taken very seriously, just because to actually calculate anything took so long that you were far better off with other techniques at that time. So that was the data, the GPUs, and then of course those two enabled much more innovation in the use of architectures, particularly recently in the last few years. I mean, yes, it's all sort of backpropagation based, which was developed, I forget exactly when, but mid-80s, if not earlier. But since then, we've developed essentially a new paradigm of computing. You know, we started off with spaghetti code, then we went to procedural, and that was a massive improvement. Then we went to object-oriented and functional and declarative somewhere in the middle of that. And now we have this sort of new technique, which I'm struggling to get my brain around, which is effectively designing neural architectures. And depending on what you want to achieve, you need to think at a much, much more abstracted level about how you want to do that. So, for example, in vision, you have sort of convolutional approaches, and they sort of make a lot of sense in vision, slightly less sense in other problem domains, and we're still learning how to apply which one in what way. So, and of course, the whole point of doing that is that even though you've got a massive amount of data, even though you've got vastly superior computing, you still want to squeeze as much performance out as possible, and a well-adapted architecture will do that. So I would say it's those three things interacting with each other that have dramatically changed.
What was spaghetti code? I ask you that because Randall got himself in terrible trouble once with the Spectator magazine, where he referred to the client's code as spaghetti code. So I was interested to hear you use that term.
Yes, it's probably not entirely coincidental. But, well, I mean, when people started coding, I mean, I think my first piece of code, which I'm still quite proud of, was some X-ray diffraction analysis done in 2K of memory. And, you know, when you have resources that are so constrained, you're trying to squeeze as much out as possible. And part of that involves jumping around because you haven't got, well, at that time, I didn't have the skills, but even if I had had the skills, I wouldn't have had the resource to structure my code appropriately. So the first thing that happened was to say, well, get rid of the go-tos, put things in functions, put them in modules, structure it so that you can start to divide and conquer your problem. Whereas prior to that, yes, it was just following the logic all around the place, and very soon, the only reason it worked was because with such massive constraints, you could actually fit the whole program in your head. And of course, that's no longer possible.
And then our first product venture in artificial intelligence was a product called Verdict, which was a decision modeling software.
Yes.
Can you remember some of the
concepts
we used?
I can remember that it was one of the early uses of decision trees. So you were pointing out that experts were not super keen to divulge all of the rules that they had to come up with the decisions that they made. But another approach, and so this is one early form of machine learning that predated the neural network learning, was that you could actually automatically induce a decision tree, which was in effect just a bunch of rules put together, provided that you were provided with input data and output data. And you could do that on relatively small amounts of data. So what Verdict did, it did a few other things, but its main sort of its party piece, as it were, was that it would enable you to put in your various bits of input data and your labels. I think one of the case studies we had was for assessing interviewees. So you have multiple dimensions, input dimensions, and you know what their education was and what their appearance was like, and you know how well they behaved interpersonally, and so on and so forth. And then you would have a score, would I recruit this person, yes or no? And if you provided a relatively small but fairly widespread number of examples, then you could induce a decision tree from that, and then you could then inspect the tree and say, well, do I agree with these rules? And if I don't, and of course, that could possibly have helped in having sort of fairer recruitment processes. That's certainly one thing we were trying to achieve.
I remember you were the sort of chief engineer on this, and my job was to do the testing and think about the marketing. And I think you'd built a rather dull test case around interviews, but I built a test case. It seems I get to tell all the silly anecdotes. But
is this your wife's story?
Well, what I did is I was getting a bit older then, getting worried. So I built a model around all the girls I'd known. Of course, it was a very small sample set, and I asked it which one of those I should have, tried to have had a long-term relationship.
And Marie's been very appreciative ever since.
Well, quite.
So it shows it worked.
It shows absolutely worked.
It shows the technology was absolutely robust in terms of the decision support that it gave, which is the point of the tool, wasn't it?
Yeah.
It's the decision support tool.
So we had, and really these techniques became mainstream techniques. We stopped calling them AI and expert systems, didn't we? I mean, we built lots of systems that had strong rule-based and logic-based solutions to them. And I guess the money, if you like, stopped requiring you to put an AI label on the front of things, didn't it? It just became mainstream.
Yes, my recollection was that there were a number of what were then called AI techniques floating around. One of them was production rules, if-then rules. But another of them was a thing that Marvin Minsky developed, which he called frames, but which then became objects. And so of the number of AI techniques, objects became the big thing of, I guess, from the late 80s onwards, and hence object-oriented programming, which is pretty much the mainstream approach to this day. So yes, there's very much been an approach where things are considered AI-ish, and then the ones that work just get adopted and used in the mainstream, and people in the AI community go off and try to solve even harder problems, which is as it should be in my view. I mean, it's very good.
We did try and use there was an interesting technology called fuzzy logic, which was trying to effectively build probability distributions around expressions that experts use. An expression would say, it's highly likely this person will develop this condition. And effectively, fuzzy logic was interesting because it tried to build a probability distribution around terminology that experts use. And I guess that's just been absorbed into mainstream sort of Bayesian and probability distribution models.
It's sort of Bayesian nets these days, isn't it?
Exactly.
Which is, I don't know if there's any significant differences between that and fuzzy logic, but it sounds very much like the same thing to me.
Yes.
Certainly the objective of providing answers in the form of a distribution as opposed to in the form of a categorical yes, no, or red, green, blue type of statement. That's what they're for.
Yeah. I'm interested now, Kaz, sort of 33, 34 years on, of what you would find really interesting to work on in AI. If you were off to do a PhD now, what would you like to study in this field? What do you think are some of the really interesting areas to do some research on?
Oh gosh, there are just so many.
Yeah.
It is. I think it was Steve Jobs said that focusing means saying no almost all the time, and I'm terrible at that because I get interested in loads of things, but I don't know about a PhD, because that I think would be slightly different set of objectives. But in terms of AI, use of AI, my sense is that the theoretical stuff is getting very hard and also very resource intensive. if you want to do real breakthrough stuff, you probably need a very large compute budget. But on the other hand, there are so many new techniques, certainly in the last decade, that one can barely keep up with them, let alone apply them. So my sense is that all of the fruit that was sort of hanging up high out of reach is being dragged down by these new techniques. I mean, I'm thinking things like vision, for example. We didn't know how to do vision properly 10 years ago even, whereas now it's almost a turnkey approach. And so if you think of all the things you could do just by having a computer or a microcontroller be able to see something and take appropriate action, it just strikes me that there are just a tremendous number of opportunities there. So I think I would be encouraging other people to say, by all means, keep an eye on what's happening at the cutting edge, but also look to see, well, what are the things that have shaken out over the last few years, and where can we apply them? I think that's a very exciting area to go in. John, why did OCC decide to support the AI fellowship at Oxford University?
Yes, so a number of reasons for that. First of all, actually, when you're a new organisation, you come into any environment, and in our case, we came to the Oxford environment. We found it was extremely difficult to make connections into the university to sort of build the contacts with the academic world. Now we've, as we're older and wiser, we know more people, and we had this opportunity to get involved in this fellowship in AI machine learning, and really we felt it was a unique opportunity to make sure that we had the opportunity to keep abreast of what was happening in the field, to have access to one of the leading experts in the field, because very often on our projects we're just constrained to work on what our clients want us to work on. But actually what we try and do as a company is make sure we have a broad expertise that we can come along and say, well, we've worked on, or we've been involved with professors and research in these areas, and we have access to expertise in different areas, so that when we're working and hoping to get customers to work on new projects with us, they're convinced that we can connect into the right networks to enhance our own knowledge. I think also it's an opportunity to support the academic work. I think industry-academia relationships are really important in this day and age. You need to invest in innovation that's coming out of universities is important. I was listening the other day to the fact that in Europe, none of the companies in the top 60 stock market companies were formed in the last 40 years, whilst in America, over half the companies in their top 60 valued companies were formed in the last 40 years. So something has to be done to make sure, because the problem isn't in academia. We know that there's excellent working going on there. Something's going wrong in transmitting that expertise out into the industrial settings. And I think also we're very keen to have this opportunity to share these conversations we're having with professors today, and the access we have into the departments with all our staff. I think when I look at a lot of the projects we do, having done a PhD myself, and I look at a lot of the projects we do, and I think actually if they were handed in as a thesis, they would be very, very good PhDs. And very often in a company, people fail to realise how innovative and groundbreaking the work that they're doing, working with clients, is. And so really this is about saying that this is an area that we have an interest in, we have the connections in, and that we're keen to encourage more of staff to take an active role.
That's right, to explore it, to see. As I was mentioning before, I think spotting a use for what's already been developed, let alone what's coming down the pipeline, could lead to wonderful new things. So yes, it's a great conduit for that.
Yeah, and to applying those in our own products, because now we're not just a company that provides solutions to other organisations. We have our own intellectual property, and a very wide and rich intellectual property in health and social care, and we do look at how to apply that into those products. So it's a great opportunity. Thanks.
Okay, well, thank you.